I the one who sent the bio? Because I was so embarrassed while you were reading that, to be fair. All right. I just realized that I was about to start this presentation by saying good morning, good evening, or good afternoon, because I was so brainwashed during past 2 years, thanks to the remote presentations and so on and so forth. Luckily enough, we are here in the same space-time and in the same time zone. Or to be more precise, I'm in the uncomfortable space of being between you and the beer. But let's just talk about legacy and then enjoy the beer. The beer is next, right? All right. So I'm between you and the beer, the last obstacle, all right? The last one. I guess, according to agenda, I'm the last one. All right. I don't want to waste our time talking about myself. Let's talk about this slide. It was displayed for a while. I guess you might have your guesses. Who might have said that? Who was that? Who has been that? I'm not talking about a particular person, right? I'm talking about the profession, because who hasn't said that, to be fair? A profession. Who might have been that? A developer, right? Of course. Of course, developer. John, the developer, maybe Cindy, the architect, maybe someone from the QA department, maybe a PM, someone from IT department. Let's face us, that's us, right? But actually, I've heard this phrase from a carpenter 2 years ago. Sorry, 2 weeks ago. Unfortunately, my apartment got flooded, and I needed some people to help me up with the renovations. There is a wooden piece of furniture to be replaced because it was demolished here and there. And so I called him up. I offered my money up, and I wanted his service. And he said, well, after I explained, well, I don't want to do that, because it sounds like digging in the old legacy project, whereas I can start something else from scratch with the current market demand, right? At first, I was shocked, to be fair. Like, here I am offering up my money for you to come and fix my furniture, and you don't want to do that. But then I realized two things. First thing, I understood him. Because there is no more new learning for him, thanks to choosing my project over someone else's. There is no more new, I don't know, dopamine hits, knowledge, no more new money, to be fair, the same amount of money. So I understood him. The second thing that I realized was the fact that we behave in the same way. By we, I mean the IT department, right? The same way. Whereas he has a point, and sometimes we don't have a point. What I'm trying to say is that not every legacy project is the same. For the carpenter, the only thing that differs is the color of the material, the shape of the wood, more or less is the same. For us, it's not the same. Even we tend to believe that a legacy system equals any other legacy system, whereas it's not like this. A greenfield also is not the same like any other greenfield. And I will try to prove that point during today's presentation. So this is just more a personal story of my personal story, to be fair. And past 12 years, I've been doing many legacy systems as a developer, refactorer, architect, creator, maintainer, auditor. And I've learned many things. I think so. I like to think that I've learned many things thanks to that. Turns out that you can actually like legacy system. Turns out that you can be attached to a legacy system. I'm not talking about emotional attachment, okay? I don't suggest that. I'm talking about actual liking, the feel of ownership and pride after working in a legacy system. You can feel that. So the personal story, and maybe there's someone from you who is working on a legacy system, and you are facing the same challenges like I did many years ago. Because I'm gonna be honest with you, I did complain a lot about legacy systems. I did complain many years, I should change positions and so on and so forth. I did complain. Maybe there's someone who's facing the same problems right now. Maybe after this presentation, you will change your perspective. Maybe not, we'll see. That's life, right? But maybe there is such a person. I want to make one thing clear. I'm not getting paid for advertising legacy systems, okay? It's not like the sponsor of the conference paid me because they are about to, I don't know, acquire a huge, gigantic legacy system that all of you are going to maintain for the next 10 years. If that's the case, I wasn't informed, okay? I don't know about, I wasn't on the agenda. I am getting paid for that, but I was the one who proposed this topic. And why? Because I think we don't talk enough about legacy systems in our industry, and they, let's face it, they surround us, right? We talk about technology, we don't talk about legacy system. What is a legacy system anyways? Maybe let's start with this. I guess that if I ask each one of you to write down on a sticky note what's a legacy system, we will have different definitions. The more people we ask, the more definitions we have. Some of you would say that's a system without automated tests, right? Or maybe a system which doesn't use the latest and greatest technology. Or maybe a system which wasn't written by myself or my team, or a system that went to production, whatever. I don't fully agree with each of those definitions. I partially agree with all of them. So let's agree my personal definition of a legacy system just for the sake of this talk. A legacy system is a system where you feel fear while changing that. And that's it. You don't feel comfortable while changing the legacy system. With your small, tiny little change, you have to be very careful to put that new if statement so that the entire construction won't collapse. Sounds familiar? Right? Yeah. You have to be very careful because maybe some distant element of the system, not related, will collapse. That's a legacy system. It's not about technology. It's not about tooling. I may even have latest and greatest cutting-edge technology, like apocalypse of 3K technology. Have you ever heard about apocalypse of 3K technology? Kafka, Kotlin, Kubernetes? I may have that and still fear while changing the code base, right? Because the deployment strategy does not constitute a legacy system. It's all about the structure. I can have crappy structure, try to put it on the cloud, and now what do I have? Crap in the cloud, right? Nothing has changed. I can have poor architecture and try to package it nicely so that it looks nice. That's a random car. Might be different. I can have a straight crankshaft, that's a part of a vehicle, and tune the exhaust system so that it sounds like a cross crankshaft. So that there is eye catcher, or in that case, to be more precise, ear catcher. We do the same with our software, let's face it, right? If we read any job advertising portal, job listing portal, they look like Tinder, right? We only put the nice things about our software there. And we lie about it. Because we want people to work with our software, that's normal. But it's not about new shiny things when it comes to legacy software. I can have all of the greatest and latest technology and still feel frustrated because I have to work with that system on a daily basis. I've been in situations like this, to be fair. And also, from the people I know that work with legacy systems, and also from people that work with latest and greatest technology, like cutting edge, really. I hear sentences like this. I would like to learn how to do architecture. I would like to learn how to do domain-driven design. I read all the books, and I still don't know how to distill aggregates. Aggregate is a technical pattern from domain-driven design. I was told that if the presentation would be too technical, people would run away. It's gonna be a bit technical, but not too much. Hopefully. So I have to switch positions. I have to switch positions so that I can find a new, brand new greenfield project. Because here, they don't do DD. No, you don't. You don't have to do that. That's not the end of the presentation, by the way. I'm trying to prove that point. Let's compare legacy versus greenfield. Let's talk about differences. Let's talk about what happens here and there. In either of those classes of systems, you have some sort of business requirements, right? In legacy, you have them probably already implemented in some way. In greenfield, you are about to gather them and implement them later on. So let's have some business requirements. Something about a delivery, something about the number of this delivery, something about a good established history of repayments by our client, and something about ledger book. Many different requirements. As an organization, you probably have your own preferred way of gathering, analyzing, synthesizing of business requirements. Might be user stories, maybe user interface mockups, maybe business process diagrams, maybe UML, maybe mixture of that, maybe web sequence diagrams, maybe popular nowadays technique called event storming. Whatever you have, use such a technique to visualize the process, synthesize the information, gather the information, find risk, and so on and so forth. At some point, like if you use UML, you will spot patterns that you are already familiar with. Like this is a composition. I can use composition here. That's an arrow with something at the end in UML, right? Or maybe if you use event storming, you can distill patterns like, oh, this is an aggregate. I know how to implement that. I know how to do that. On the left side. On the right side, there's a different aggregate. In between, I have a policy which integrates to aggregates so that they are consistent if they need to be that, right? I can even call it aggregate. Maybe inside I will implement value object, technical patterns, doesn't really matter, entity, and here I have policies that integrate two different subsystems, let's call it that way. So I know how to do that in a greenfield, right? I can now sit at my desk next to my keyboard and start coding. I just signed the paper for my new employee, right? Employer. But you know what? Something has happened. It was supposed to be greenfield, while we're talking about my salary and so on and so forth. But then, when I signed, just for 2 months, I will have to do some legacy, just for 2 months. Happened never to no one, right? Really? It happened to me. Like 4 times. All right, so just 2 months. 2 months near our great, big, legacy, gigantic system. 2 months near a black hole. What happens with 2 months next to the black hole? Who is good with physics? Thanks to the time dilatation effect, 2 months becomes eternity, right? The time flows very, very slow thanks to the gravity force, right? So it's 2 months next to our legacy system. And instead of doing greenfield with this, right, I'm doing legacy, so it's already implemented somewhere. Instead of this, I have that. So 2,000 lines of code everywhere. 1,000 modules. Weird abstractions, wrong layering. Very thoughtful and clever patterns left for us by our former colleagues. Very, very clever and thoughtful. So clever and so thoughtful that we want to give those developers a huge hug, right? Because it's so clever and easy to understand. But then you try to look at the code base, and there is a SOAP request, there is an insert to the database, there is an if statement, there is external service being called, there is one-to-one mapping, there is another if statement, there is a trigger, there is a filter. Now we change the database in SQL like animals here. Here we have field change, here we have if statement, here we have a scheduler, here we have a person who's casually integrating to system each day at 6 o'clock because we didn't have time to automate that. And you try to wrap your hand around this. Here is an event listener or something like that. You try to wrap your head around this and you feel like Lucas. Lucas is my best friend. And I took this photo while we were hiking base camp of Mount Everest past year. And at this altitude, people live there. And there is shortage of building material. So the only material they have is stone. If you build a building out of stone, it has holes. So they try to fill holes with something. The second material they have is feces of an animal called yak. So they use it all the time to fill those fillings. So that's their architectural pattern. I thought that's a nice metaphor with what we do with our software sometimes. We feel like Lucas. But at some point, as Lucas, you become fluent, you become elastic, you become flexible in this code base. You start noticing patterns, like this if statement, when it's true, only then I can change this field. Same applies to this filter, and same applies to this insert and that if statement. So this is all related, even though it's spread across 20 different modules. But I always change this code, and this is always consistent. This is area of consistency. We have a pattern for that, to making sure some business rules are consistent all the time. It's called, in domain-driven design, aggregate. So this is an aggregate. Even though it's not like in the books, right? It's not shiny and brand new, but this serves the role of an aggregate. That's this, right? Even though I don't have aggregates in legacy, it doesn't mean I don't have something which plays the role of an aggregate. Replace aggregate with any other pattern you would like to have. That was legacy, right? What happens in greenfield? In greenfield, you are about to implement your brand new shiny model. There's no one stopping you from that. Finally, I can do that. So what happens? I have a code. It's well structured, well tested, well modularized. Everything is fine. It's even reactive. I even deployed that on Kafka. I have 10 users per day, but I could use Kafka, so I use that. All right. But then, after 2 weeks, after the first release, something has happened. No one could have predicted that. Requirements changed. So I have to add something to my brand new model. Like there is a new important information, like an edge case, like a business new information, very essential one that we need to implement very quickly. So adding something to my naive model. It was so shiny, but it turned out to be a naive model. All right. I don't have time to start from scratch, so I'm trying to fix code around. I'm adding something here. Maybe I'm adding something here, new if statement. There's new important information coming after next 2 weeks. I'm moving things around so that we can quickly deploy. It's a greenfield. We have to react to rapid market changes, right? Very quickly. So I'm quick. I'm changing code. After a while, it looks like this, right? After 3 months. But it started very nicely. Look at this from the meta level. If I talk about changes in any business model, in any software, almost any software, they tend to be more stable over time. Even though it's maybe not the best quality, but thanks to the fact that the essential information is coming each week on production, you have more information and less changes. Because we are revealing new edge cases, new bugs that needs to be polished and so on and so forth, right? This is what separates legacy from greenfield. This line. Legacy, I have more information. That might be obvious, but what's not obvious is that legacy shows us, and this diagram shows us that time is the best bug fix. What do I mean by that? I mean that time is a great source of information, and where do I have more time? I mean elapsed time. In legacy or in greenfield? In greenfield, I have amount of elapsed time equals to 0, right? Because we are not on production yet. In legacy, we have probably 10 years of information gathered in our code base. So time is like quality verdict of our software, I would say. I'm not talking about software quality, but I'm talking about how many different use cases are we exposing our software to each day. So with each day, the risk or the possibility of finding a risk or finding a bug in our software decreases. Thanks to the increasing number of use cases we expose our software to. That might be obvious, but we don't think about this in greenfield. What I can do with this? We have more time, which means more information. What I can do with this essential information so that I can actually learn from working in a legacy system. I can use it as a learning artifact. Look at this. This is this aggregate, right? That we all talk about from the books, that we all talk about at the conference, that we all want to implement in greenfields. This is something that should be implemented with an aggregate, but it's not. But now, as a modeler, I can see that there is a space for an aggregate, which gives me advantage, which gives me modeling input, which gives me learning input. Oh, I could do it. Maybe I will not be given time to implement that, but I know that this is a place where it should be done. After some time in legacy, think about it, we have more invariants, more business rules known. We have places where a nice value object should be implemented already there, of course implemented with different patterns, but like Lucas, but already there. Places where a brand new shiny architectural pattern like, I don't know, Saga or Process Manager would be a good fit is already there, implemented with 700 lines of code across 20 different modules, but it's already there. I can fix that, or I can at least see that. Notice the words that we have used: invariants, aggregates, value objects, policies, sagas, and so on and so forth. Legacy software, if it has rich domain, and legacy software, they tend to have rich domain, the problem space is rich. Legacy software teaches us how to do domain-driven design. And if you feel like this is hard, spotting this, you are right, it is hard. No one said it's going to be easy, right? But what's hard, it's also rewarding. And I'm not talking just about money, although, yes, I know plenty of companies that would pay us big bucks for fixing their COBOL systems because they don't have anyone to do so. So yes, it's also about money, but different kind of reward, like learning, knowledge, experience, dopamine hits, etc., etc. And how to spot that if that feels hard? So I sometimes start software audits if the target is to refactor into more domain-like patterns with these heuristics. I cannot stress that enough. It's a heuristic. It's not a strong rule. If you see even in your legacy a repetition of constraints in the database, or maybe a repetition of different business rules in if statements, and they are all very related to each other, that's a place where you can have an aggregate. If you see a repetition of different if statements, like syntactic if statements that are validating something, that's probably a nice fit for a value object. If you see repetition of yet another form of if statement, the coordination if statement, the coordination if statement is like this. If it's Friday, also send it to our, let's say, old legacy system because of reporting reasons. That's a coordination if statement. If it's mixed with event listeners, schedulers, external system calls, that's probably a place where you can implement a Saga or policy or process manager. If you see a repetition of the same sequence of if statement, followed by changes to some state, like via setter, for instance, that's a place to encapsulate this code into a domain service. And if you see a huge, gigantic service, I call it entity-based service because if I have credit card entity in my database, probably I have credit card service with 10,000 lines of code, with hundreds methods. Each of them has hundreds of lines. One of those methods, each one, is a candidate for an application service, a use case. That's a use case in your system. We can encapsulate that use case. That's called an application service. These are a list of heuristics, right? And then, thanks to this, you have a natural refactoring order. Again, cannot stress that enough. It doesn't work that way always because every refactoring has to be put into a context. But from my experience, sometimes or very often, this set of steps is beneficial. Like we start with low-hanging fruits, starting to see some value objects, then gathering them into more cohesive forms that are encapsulating business logic, which is related to each other. So aggregates. Of course, they will be big at the very beginning because you move the firewalls to the inside, they will be big. Of course, your classes will be big after this kind of refactoring because they were big at the very beginning. So you have a lot of getters there. But if you take a look how those getters are used, you probably will notice this pattern in almost every legacy. Someone saves the data to the entity so that it can always be displayed after all or later on somewhere on a read model. So saves and reads. That's it. So it's like a placeholder for our data. If it's a placeholder and has no other purpose inside of this class, I can use a different placeholder. Like here, and call it read model. And thanks to that, I have now two smaller objects. One of them is called an aggregate, which makes decisions, and the other one is a read model. Some people would call it CQRS, Command Query Responsibility Segregation. Has anyone heard about this architectural pattern? Some of you. People say, I want to do greenfields because I want to do cool patterns like CQRS. If I had a dime every time I hear that, I wouldn't be a millionaire, to be fair, but I would have money to fix this apartment, to be fair, because I forgot to renew the insurance policy. So yeah, I would have money to fix that. There is plenty of space to do CQRS in legacy systems. I start software audits sometimes with CQRS when we fix queries because they were slow. Plenty of space. We talk about those entity-based systems, entity-based services, and chunk them, divide them into smaller, more cohesive application services. That's a natural step, next step. Not only legacy software teaches us how to do domain-driven design, how to do architecture, thanks to the information which is gathered over the years, but also it teaches us what questions to ask. What do I mean by that? Take a look at this. Let's say we have already implemented system that sends, I don't know, cabs or taxis. And there's a new requirement coming. Of course I will implement that with if statement, right? Of course. But then I have a new requirement like this. Next if statement. After 2 weeks or 2 months, I have 10,000 of if statement and no one wants to touch that code. It's very fragile. I have to be very careful and I feel fear while changing that. Pure definition of legacy, right? But what happens if I am already meeting code base like this? All right? I already have this information gathered. Remember the red dots? It's already in the code base. Maybe implemented in this way, like a script-based, crappy way, Lucas way, but still, it's already there. And next time, after me analyzing this kind of information from legacy, if I face a common requirement like this, a very similar one, the same application, maybe in a different application, the requirement might sound a little bit different, like a player with 10 points on board XYZ gets 10% discount when buying a sword, for instance. It looks different, but to be fair, it's almost the same, but the domain differs. But now, if I'm in a different system, next project, maybe next domain, I will remember, hey, I've seen something like this. In the previous system, it was implemented with 10,000 if statement, and I remember how it ended up. It wasn't a happy end. Now, I know that, well, this is a specific discount. We'll have different ones. Flat-based, subtract-based, percentage-based. Just like in the previous system, probably. I can ask questions. Hey, do your business, do you predict different count of discounts? Of course. That's obvious. I also see that the client plays different roles, just like in the cab system, the taxi system. The passenger is not always the payer, because sometimes their company pays for them, or maybe wife or husband or parent, whatever. So we have party-to-party relationship that we have to implement, right? The passenger is not always the one who pays. Most possibly, in most cases, yes, but not always. And I can ask this question, yet right now, because previous legacy taught me to do so. And this is just a specific strategy. It can be any other, like it can be anyone who has a surname which starts with B on New Year's Eve. So now I know that I have to implement 3 different models, and this little sentence is just a small integrator on top of that. And now I model it's more and more extensible and composable, thanks to the fact that I have seen that somewhere, right? But it requires me to be curious. It requires me to ask questions and to analyze this legacy system. I guess you are curious because it's, what, 5 p.m. on Thursday, and you are on the software conference, right? Unless your employer forces you to do so. In that case, the beer is coming very soon. So it requires being curious. But if I am curious, legacy will teach me things that are impossible to be taught in greenfield because of the elapsed time. Some people would say, so what? Oh my God, who the hell cares? I cannot implement that. Exploration without code is just code. Sorry, it's just exploration. What can I do with that? The code still looks like this. All right, you can't do anything about the code, maybe, I agree, but if you think about how we deliver software, we first hear about requirements, then we think about how we could model that, then in legacy, we probably see some implementation. It's not step number 3. Of course, the code will ask me difficult questions and challenge me with my assumptions, but the most efficient way of learning happens at the stage number 2. I learn the most about architectural patterns like aggregates while distilling aggregates or modules, not when I implement them. When I want to learn how to do C++, of course, I learn the most at stage number 3, but if I want to be a better modeler and architect, I learn the most at state number 2. So even though I can't implement that, I'm learning in legacy. All right? The most efficient, the best architects I know, they can say that, hey, this requirement in current model, it's almost impossible to implement because they can see that if that needs to be changed, the model should be changed here, but in current implementation, I need to go all over the place and do shotgun surgery, right? And change all over the place. So I can learn. Some people would say, but it doesn't work in our company. Our company is specific, it's special. It can't be done here. Maybe anywhere else, but not here. We are doing a specific product. It's different here. All right. What does it mean it cannot be done? What does it mean? No one will give us time to think it that way and to even implement that in that way. All right, so think about it. Let's summarize. You are working with a software and you say that the software is of low quality. Some people would say that, right? You preach that it can't be changed. And there's nothing we can do about it. You complain about this software. Yet you still work there. From whatever reason. So, taking into account those 4 things, why not having a single solo benefit out of this situation and learn to analyze what was going there? For my individual needs, maybe I will use it in the next project, all right? But I wouldn't be myself if I wouldn't ask why it can't be changed. Because people won't give us time. Why they don't give you time? It's probably because there is no trust between business and IT, right? It's a common situation. When there is no trust, no one gives us time. That's normal. Why there is no trust? Probably we have failed several times, right? Trust takes weeks to build and moments to lose. But how I can gain trust thanks to this and thanks to analyzing legacy? If I have a map of the architecture that could look like this, it's not implemented in that way, but could be looking like this. Now I can go to business, maybe I can even print it out, send them to them, and hang over the desk. And now we can talk about our architecture without technical words. To understand technology. Right? Now I can talk about our software, and the business people have a tool to estimate what shall be changed when a new information or new business requirements comes. They may think like, all right, I need to talk about, need to change this stuff and that stuff. I should talk to this product owner and that product owner. That's a better estimating tool. That's also a situation where we as IT, we feel like maybe we look more professional, to be fair. But then, our answer will be, dear business, we could talk in that way, but the software doesn't look that way. But if we have time, that's the artifact that we are trying to have with you. All right? So I'm giving you the ready artifact, and now please give me time for that. And then we could have those kind of conversations. Then you could have better estimate. Then you could have better teams alignment, and you would know which product owner to talk to, etc., etc. And maybe not. Maybe that's not possible still. It happens. Depends on the organization, right? But if that's not possible, still you have your individual needs. and individual learning that you can use being in this legacy. That brings you to the point of mental models. When we are solving any problem, we use mental processes in our brain, right? And we use the same mental processes to implement code as we use to when we are solving any problem beyond the keyboard. In other words, evolution wasn't kind enough to equip us with coding center, at least yet. What it means is that we have a mental representation of a problem in a set of neurons, and it becomes stronger and more stable the more we practice. And psychologists refers to these models as mental models. They are brought at a particular event when we are solving a particular problem from our memory to our working memory. And they are more stable if we practice. If you are a C++ developer, have you ever thought why you don't have to learn C++ when you change projects? It's because understanding code also builds on mental models. You have a general mental model to understand code, to understand semantics, syntactic of C++. You don't have to understand yet again why there is such an order in the constructor hierarchy in C++ or how to interpret Haskell, because you already know that. But how was it at the beginning? You have to learn that, right? That was the knowledge at the very beginning. But then the model became stable, and it translates across different projects you work on. Guess what? You also have mental model to understand business needs and to implement them. The more you practice, the more stable it becomes, and the more profitable and efficient you are in the next system you are working with. But you have to have examples of business rules. Where to find them? In legacy. It's already there, implemented in the crappy code base, but the information is there at your hand. You can take it. You want to learn domain-driven design and architecture? Explore legacy systems. Said no one never, unfortunately. At least I haven't heard that. But it's a great source of learning. But people say different things. After every training I do, and I do a lot of training for architectural needs, for domain-driven design refactoring, I get this question. Can you point me to realistic domain-driven design examples? I personally have one, and people refer, not yours, it's too simplistic. Or not the ones from the books, because they are too theoretical. There are examples. They have to be simplistic, by the way. But now I answer this with this. You have it on your HDD in Git, probably. You work with this with your legacy on a daily basis. If the domain is rich, that's the best source to get information how to learn architecture. Git, your source control. Actually, your source control, just like legacy, is a great source of learning domain-driven design. That's a brave hypothesis, right? Git, source control. I will try to prove it. Git is like a witness. It notices everything. Everything that has to be done by you or your teammates. It's silent, it's quiet. It doesn't judge you, right? Unless you type git log. Then you have all of the information revealed from the past. So Git is like, I don't know, your mother-in-law, right? And Git is source of information as well. I was about to say just like your mother-in-law, but I don't know that. Anyways, what kind of information? Not only obvious information like heuristic about what should be kept together in code, because now we change distant element of the code base in every commit always, and these are kept separately or in the ticket. I can get that from Git, that's obvious, but I can find something more. I can spot places which are so-called nodes. I call them nodes. Node is a mixture of different business models implemented in one huge gigantic place, which no one wants to touch because we feel fear. Because it's mixing many, many different problems in one place. That was a node, right? That was a node of many different things, many different colors, many different ropes, mixed together in a node. Node. This. I will tell you a story how you can use Git to learn from your legacy. Once upon a time, I have been working as an internal employee, and I have to obfuscate the example. So imagine the problem space was about agricultural machinery. We are developing a system who would lease machines to people, to farmers, like for hours and so on and so forth. It was very rich, user interface, payments model, reservation, transactions, CRM claims, and so on and so forth. And one day, business came and asked us, that wasn't a question, by the way, that was a statement. I now remember. The statement was like this: we made a deal. In 3 months, we want our system to lease cars. That's almost the same, right? Like doing agricultural machinery. It shouldn't be that hard. Of course, it was super hard. It was impossible, to be fair. It's you have 3 months. The deal is signed. By the way, the penalty is 10,000 euro. You have to do it. So there was a team aligned for this, and they had 2 different options. The first option being, we start with greenfield, but yet we had this user interface, the payment model was almost the same, the claims model was the same, people were familiar at the back office with the user interface, so that wasn't the case. Plus, they had 3 months, impossible, 5 people. So they started tuning and pretend that like the agricultural machinery can be a leased car. It didn't end up well, to be fair. They went on production, but the system worked in an app. The system worked in an absurd way. So we couldn't continue like this. And my team was brought in to help. And I made a controversial decision that we cannot help by doing greenfield because they failed. We would have failed as well. There's no more time for tuning. They also failed with that. So maybe we should delete everything in the code base, which talks about machines, and then implement the greenfield model of cars and connects everything. So do like heart transplantation, right? And the decision wasn't done out of the air. Git helped us. When we are analyzing code, notice that like those 2 things were changed together all the time. Those as well, those as well. To be fair, everything was coupled to everything else, like in pure legacy, right? So what we started doing, we started also noticing the pace of changing the machine model combined with any other model, which was the periphery of that system, if the machine was core. And we started doing the following thing. The code base for machines. Command F, looking for machines, did classes, functions, tests. Of course, the code stopped compiling because we are using a language with a compiler. In that case, it was Java. But we are starting implementing the greenfield in the brownfield and then connect one by one. It took us weeks to finish. Needless to say, we didn't have continuous deployment like in the currently advertised best job offerings. We didn't have delivery continuously as well. We didn't have continuous integration. We didn't even have continuous compilation, to be fair. The code didn't compile for the first 3 weeks. Yet everyone wanted to work with us because we felt ownership over this code and we are knowing what we are doing with the new model. That was a greenfield in brownfield. If you continuous compilation in a greenfield project, no one talks about it, right? Comes only with legacy. Change coupling is the thing that we are looking for. So Git helped us to notice the thing. Those 2 models will change altogether. Those as well, those as well, those as well. But machines and transactions and payment and reservations, of course they will change together as well, but the degree was the smallest. That was our clue, a hint from Git and the legacy that maybe that's a hidden boundary. We can delete and we can risk to implement a new model and connect everything else. And we managed to do so. 3 months, big success. Now the system is deployed in several countries. From what I know, it's still working. If you want to know more about this kind of analysis in Git, in legacy, this is the book, Software Design X-Rays by Adam Thornton. Great book. You can analyze even to the level of a method. What is correlated and what changes with what else. Because in legacy, we already have those so-called bounded contexts, so very important pattern from domain-driven design that everyone talks about, but these are hidden. We have to find them. They are not bounded. They are implemented in that way, but the colors are already there. Implemented like this probably, but when I look at the code base, I see this is probably not. And legacy teaches me to analyze code base in this way and to be a better modeler. We often discover those contexts in legacy, discover models. We don't propose them. They are always horizontal, not vertical like in the books. Because not everything is perfect. Nothing is perfect in legacy, to be fair. So if you want to understand bounded contexts, by the way, bounded contexts are prerequisites to microservices. We have to understand them if you want to understand microservices. Explore legacy systems. Again, no one never has said that. At least I haven't heard about this. What else can I do with Git? If you analyze lines of code in your code base, there will be those so-called peaks, right? It might be one class over time, how it changes. When I start a software audit, I don't have time to analyze every change past 10 years. So I look at the peaks. What has happened here and there and there? I call them WTFs. What happened there? And then I go to the code base, I look at the specific commit, I try to find the story behind this commit and find maybe some information. You will see what kind. It might be lines of code, it might be complexity metric, whatever. And you will find this, probably, in the code base. That was one class. Probably those peaks are continuously adding new different business models to one gigantic model. That's a heuristic, of course. That's how I can spot what was happening in a legacy system to one gigantic big node, like this. Maybe that was behavior related to payments, this to reservation, this to machine, and it's all kept all together. Thanks to Git, I can find that. Again, just like with models, in legacy, we often discover those objects and boundaries between them. They're already there, but we have to discover. There should be the boundary. Legacy teaches us how to prioritize software. My mental metaphor of a legacy is an archipelago of ugly islands, to be fair. They're all interconnected. The connection sometimes is underneath the water, beneath the surface. But they're all connected. If I want to change something here, I need to know the impact. Maybe the impact is over there, maybe over there. I don't know how to find impact, how to estimate impact so that I can work locally without destroying the entire universe. So there are various ways. You can analyze the code hierarchy, the database hierarchy, the user interface behavior, and so on and so forth. One technique I particularly like is to analyze business requirements. If you see business requirement like this, as a user, I want to pay for the package. If I have enough money, the package changes the status to paid. You probably are familiar with this kind of user stories, right? Have you ever seen a user who would like to see the status to paid in the database? I have never seen such a user, to be fair. This is not the final business consequence that I'm looking for. It's not the report, yes. It might be better, but it's not that. What's the final consequence? Probably, as a user, I don't want the status to be set to paid. I don't care. That's implementation detail. I care that the product is reserved. No one else can buy it. That's the final business consequence. Now, I know that if I change something in the payment model, I need to check the reservation model as well. So I'm writing tests. When something in payments, then not in payments, something was set to paid, but I'm checking the reservation model. Legacy teaches me how to be a better tester as well, because I learn how to estimate impact. It teaches me how to understand causality in our software. It teaches me how to understand cause and effect relationship. It teaches me how to be a better business analyst, to be fair, as well. It teaches me patience, because I can't fix all the things at once. That was my problem years ago. I wanted to fix everything according to the books. It's not possible. We have to deal with that. It's not possible. Also, it teaches us patience in the way that, you start with a new requirement, maybe with a new test that you would like to implement, and you fail. Of course you will fail. Then yet again, you try and you fail. You try and you fail. After several times, you are frustrated. How many of you exit the task when you are frustrated? Keep your hands up. Some of you. Keep your hands up if you are under 25, or over 25, sorry. So that's the case. It's not about your age, of course. What I'm trying to say is that frustration is the state of mind when we learn. Frustration is when two different neuromolecules are released in your brain. One of them is called epinephrine, the equivalent of adrenaline. The other one is called acetylcholine. Those two molecules, they are responsible for making your brain elastic. This is when you actually can change your behavior. Trauma has the same effect, by the way. No, cocaine, not. No. It works on a different system, but nice try. It teaches us how to be patient because we have to overcome the state of frustration. Those two molecules, they say, hey, something doesn't work. You have to fix something in your map of neurons. I ask if you are under 25, because if you are under 25, your brain is plastic by default. You don't have to do anything. If you are not, I'm sorry, you have to find tricks, like being frustrated is a trick. Side note, the brain doesn't care why it got frustrated. So I can try to shoot a basket with a ball. I can face 50 times, be frustrated, and now I'm learning Spanish. You can do that. And you can learn Spanish efficiently that way. Same applies to our software. And I know that there will be frustration, but also I know that at some point I will be successful, right? But I cannot lose the enthusiasm of that. I have to overcome that state. The wise man from history also tells us that, right? Success is the ability to go from one failure to another without loss of enthusiasm. And another great source of quotes says that there will be success because that's the only option. Failure is not. I call it the Churchill Eminem rule of legacy. I'm a strong believer into that rule, to be fair. Legacy beats almost every ego. Almost every ego. So back in the day, I would say things like, I'm not going to test business logic on HTTP calls because that's not what the books say. I won't going to test using pure DB scripts because that's not how it's supposed to be. You know what? Sometimes you will, because you're a problem solver. And you know that you are not a coder, but a problem solver. And if the problem requires something like this, and if it solves the problem, then that's the good practice. Good practice is always good unless someone finds a better practice, right? So theory is theory, good practice is good practice, legacy is legacy, and teaches us how to be fair, better programmers. You look at this with your ego, and then you look at the implementation, 20 different models, millions lines of code. But it somehow sometimes works and pays our salary for past 15 years. And managers are driving Panameras for delivered KPIs. It must be working, right? Somehow. I don't know why and how, but it's working. It's delivering profit. I once had a eureka moment, like Copernicus, with his geocentric theory. I thought about, when I was a junior developer, I thought everything was about the code base. Like, the code is the thing. The company has some other departments, but who cares, to be fair? Here, it's where the magic happens. Next to this keyboard. Of course, the keyboard was mine. And then I realized that the system is not code-centric, but business-centric. The IT system is always smaller than the entire business, right? There are people working with this system, and they make sure the entire system, the business system, is successful. The code is a very important part of that, but still, that's a part. And I can fight the code, and I can complain and leave and probably repeat the cycle in the next company, or I can just learn from this situation, right? Because legacy teaches us how to be more humble. At least I like to think so, to be fair. I'm not sure about this. That's it. That hard skills, these are like less difficult than those which we call soft skills, but also soft skills can be learned from a legacy system as well. It's like this. You try to overcome the frustration, you write this first test. You fail. At some point you succeed. You have the first test. And then the second test. You show the path to other people. They will follow you. At some point you decide, hey, I have multiple tests. Maybe we can try to do some more advanced refactoring, like not method extract but it's like extraction or distillation of an aggregate or a new model. I feel more comfortable. At some point, when you finish that, you have more dopamine hits, you get addicted to that, to be fair, like to the cocaine you mentioned. And you're like an avalanche, to be fair. You cannot be stopped right now. In Polish, we have a saying, you are like Tommy Lee Jones in The Fugitive, Tommy Lee Jones w Ściganym. You are like this. And people would say, it's easier said than done. Of course, like everything. And it's easier said in my case because I work as a consultant, so I spend 3 weeks or 3 months with a team. Yes, it's always easier to get your advice implemented if you're an external paid consultant, of course. But I'm talking about this from the position of the internal employee as well, because I've been there for many, many years. And I complained for many, many years. I would still complain today, by the way, if I don't like something. But then I realized that, well, that's when we learn. I just think that engineers and people who work with IT systems lead better work life if they are capable of solving problems. But I'm also this close from realizing that the best life is led by people who can learn to ignore problems. But I'm not yet there. Thank you. If you have any questions, I'm here and I will be there for like the next 2 hours probably. I wish you a great after party and I hope you had a great time today during the conference and thank you for having me today.